All right, let's talk about one of the biggest, oldest puzzles in all of mathematics, prime numbers. For thousands of years, they've seemed completely chaotic, but today we're zeroing in on one of the first people to find a real honest-to-goodness clue hidden in all that noise, a mathematician named Adrien Marie Legendre. This is a great story. Let's get into it.
I mean, think about that question for a second. It's a huge one, right? Prime numbers go on forever, we know that. But how do they go on? Is there a map? Is there any way to predict where the next one's going to pop up? How do you even begin to chart a territory that literally never ends?
For the longest time, it just seemed hopeless. They felt, well, totally random, almost defiant. You know the sequence: 2, 3, 5, 7, then a jump to 11, then 13, 17, 19. The gaps between them just grow and shrink with no obvious rhythm. It was this massive, fundamental mystery at the heart of math, and nobody had a key.
And then, this happened. Around the year 1800, this book, Legendre's Theorie des Nombres, hit the scene, and it changed everything. Now, it didn't solve the whole puzzle, not by a long shot, but what it did was offer the first truly powerful clue, a way to estimate the pattern that was hiding in plain sight.
So let's just take a moment to appreciate what a beast of a problem Legendre was really facing. What makes this whole prime number thing so ridiculously hard to crack? Well, here's the heart of it. You've got this endless list of numbers that look random, and there's no simple, neat formula you can just plug a number into to get the next prime. It's not like adding 2 every time. This wasn't just some little academic curiosity either. This was a giant hole in our understanding of the basic building blocks of every single number. And this is where Legendre comes in with a totally different way of thinking. He realized that trying to find a perfect, exact formula was maybe the wrong way to go. So he took a step back and tried a more practical approach. He went looking for an approximation, a pretty good guess.
So in his big book, he puts forward what's called an empirical formula. And that word empirical is everything here. It means he didn't derive it from pure theory. He got it from just looking at the data. He looked at huge tables of prime numbers and tried to figure out a curve that fit them. Basically, he was doing data science just 200 years ago.
Now you have to get this part because it's super important. Legendre couldn't prove his formula was right, not in that super strict mathematical way. He was essentially just saying, hey guys, look, based on all the primes we found so far, it sure looks like they follow this general trend. It was an incredible, brilliant guess, but it was still just a guess, an assumption, not a proven fact. So, what was this amazing trend that he spotted? Well, his breakthrough idea wasn't about predicting the very next prime. No, it was about answering a different question. Just how common are prime numbers anyway? He started thinking about their density. Think of it like this. In the very first batch of 10 numbers, you've got 4 primes: 2, 3, 5, and 7. That's a 40% density. Pretty crowded. But if you look at the first 100 numbers, you only find 25 primes. Now the density's dropped to 25%. Legendre saw this clear pattern. The bigger the numbers get, the more spread out the primes become. They get rarer. His mission was to figure out by how much. And here is the beautiful, elegant part of his idea. Legendre proposed that this decline in prime density was tied to the natural logarithm. It's just so cool. As your number, let's call it x, gets bigger and bigger, the logarithm of x also gets bigger, which means that 1 divided by the logarithm of x gets smaller, perfectly matching the way the primes thin out.
And because he was an empiricist, he didn't just stop there. He saw that the simple 1 over log x idea was good, but it could be better. So he tweaked it. He added these little correction factors, an a and a b, and he fiddled with their values until the formula was an almost perfect fit for the real-world prime data. This wasn't just math. This was straight-up detective work.
Okay, so Legendre has this formula. It's not proven, but man, it works really, really well. So what happens next? Does it get forgotten because it's just a guess? Oh, absolutely not. Its impact was huge and it was immediate. For the next half-century, Legendre's formula was basically the gold standard. It became the starting line for anyone who wanted to tackle the prime number puzzle. We're talking about the biggest names in math at the time: Abel, Dirichlet, the legendary Chebyshev. All of them were looking at Legendre's work and building on top of it. I mean, this quote really just says it all, doesn't it? This wasn't some obscure idea buried in a library. It became a central pillar of number theory for 50 years.
It completely set the agenda for what to work on next, and it lit a fire under a whole new generation of mathematicians to go out there and either prove it or do better.
So here's the bottom line. Even though Legendre's formula was eventually improved upon and replaced by the famous prime number theorem, it was an absolutely critical first step. He was the one who first dared to suggest that the wild chaos of prime numbers could be tamed by something as elegant as logarithms. He didn't solve the whole mystery, but he gave everyone else the first big clue.
And that's really the thought I want to leave you with. The story of Legendre is just this perfect reminder that progress in science, in math, anywhere really, it doesn't always start with a perfect, ironclad proof. Sometimes it starts with a hunch, a bold observation, a brilliant guess that shines a light down a dark hallway and gives everyone else the courage to see what's there. It really makes you wonder, doesn't it? What brilliant assumptions being made today are setting the stage for the proven facts of tomorrow?